Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2127 indicates an issue with APP sensor B, specifically a low voltage condition detected in the throttle position TP sensor E circuit. The APP sensor stands for Accelerator Pedal Position sensor, which plays a crucial role in the vehicle's throttle control, communicating the driver's input on acceleration to the engine control module, ECM. Located on the accelerator pedal assembly, the APP sensor utilizes multiple circuits to relay data accurately. When the vehicle systems detect that the voltage on this sensor is about 0.2 volts or lower, the DTC P2127 is triggered. Before initiating troubleshooting, it is essential to check the freeze data and any onboard snapshots, and to review the general troubleshooting information to pinpoint the underlying issue effectively. The APP sensor B is integral to the throttle system, as it determines how much acceleration the driver is requesting. This sensor is situated on the accelerator pedal assembly, where it converts the position of the accelerator pedal into a corresponding voltage signal. This voltage signal is then sent to the ECM, ensuring the engine responds appropriately to the driver's input. The APP sensor comprises multiple pins, each conducting specific signals, including a 5-volt reference voltage and ground, which are essential for its operation. When the voltage levels fall below the acceptable threshold of approximately 0.2 volts, it leads to erratic or unresponsive engine performance, prompting the activation of DTC P2127. Several factors can lead to the triggering of DTC P2127. An open circuit in the wires connecting the APP sensor to the ECM can disrupt the electrical communications, causing low or no voltage to be detected. Additionally, a shorted wiring condition can create a false low voltage reading, leading to the same fault code. If the wiring checks out, the APP sensor itself may be faulty and necessitate replacement. Lastly, outdated or incorrect ECN software can cause improper readings and must be updated to ensure the proper functionality of the entire throttle system. When DTC P2127 is present, drivers may experience a variety of symptoms primarily related to engine performance. A noticeable delay in throttle response can occur, making it feel as though the vehicle is unresponsive when the accelerator pedal is pressed. In more severe cases, the engine could stall unexpectedly, leading to potential safety hazards. Furthermore, warning lights may illuminate on the dashboard, alerting the driver to the existing issue. These symptoms not only affect the driving experience, but also raise concerns regarding the vehicle's safety and reliability. In the first step of troubleshooting DTC P2127, ensure the ignition switch is turned to the on-to position. Using a Honda Diagnostic System HDS, check the readings for APP sensor B in the data list. If the voltage measures approximately 0.2 volts or lower, this confirms the failure, prompting you to proceed to step 2. However, if the voltage is above this threshold, it signifies an intermittent failure, or that the system may currently be operational. In this case, inspect for poor connections or loose terminals at both the APP sensor and the ECM before continuing with further tests. Step 2 requires turning the ignition switch to the lock 0 position and then disconnecting the APP sensor 6P connector. Once this is done, turn the ignition back to on. Measure the voltage between two specified test points, specifically between test points number 2, LT blue, and number 3, gray, at the APP sensor connector. This test checks the VCC5 line. If the voltage is approximately 5.0 volts, this indicates a proper supply voltage, allowing you to proceed to step 3. If the voltage is not approximately 5.0 volts, you should move on to step 6, where further diagnostics will be performed to identify the underlying issue. During Step 3, set the ignition to lock 0 and use the HDS to jump the SCS line to prepare for the next test. Disconnect the ECM connector A, specifically the 49P type. With both the APP sensor 6P connector and the ECM connector A disconnected, you will check for continuity between the defined test points. The focus here is on the APS2 wiring, testing from the APP sensor 6P connector number 1 per to a body ground. If continuity exists, it indicates that there is a short in the APS2 wire, and appropriate repairs should be conducted between the ECM connector A and the APP sensor. If continuity is not found, proceed to Step 4 for further evaluation. In Step 4, start by connecting terminals A and B using a jumper wire to bypass the circuit. Terminal A corresponds to APP sensor connector number 1, PUR, while terminal B is connected to a body ground. Test for continuity between these points, specifically across the APS2 line. If continuity is established, this confirms that there is no open circuit in the APS2 line, allowing you to move to Step 5. If continuity fails, it suggests an open wire between the ECM and the APP sensor, which would require repairs to restore functionality before proceeding. Step 5 involves reconnecting the ECM connector A 49P before creating a jumper wire connection between two specified points at the APP sensor. Specifically, connect terminal A, APP sensor 6P number 1, pearl, with terminal B, APP sensor 6P number 3, gray. The ignition should then be turned to on 2. With this configuration, measure the APP sensor B data again using the HDS. If the voltage reads at or below 0.2 volts, then it's necessary to replace or update the ECM if it is not equipped with the latest software. Alternatively, substituting a known good ECM could also determine if the issue resides within the module. If the voltage is above 0.2 volts, you would proceed to replace the APP sensor to resolve the fault. In Step 6, set the ignition switch back to lock 0 and again use the HDS to jump the SCS line. Disconnect the ECM connector A, 49P, and proceed to connect terminals A and B. Terminal A should be the APP sensor connector number 3, gray, and terminal B connected to the body ground. Test for continuity between these two test points with the ignition still in the lock 0 position and the respective connectors disconnected. If continuity exists, this indicates that the VCC5 line is okay, and the next step would either be to update the software in the ECM if necessary, or substitute it with a known good module. If continuity is absent, this signifies an open circuit in the VCC5 line that needs to be repaired. The final repair verification process begins by ensuring that the ignition switch is turned to lock 0. Reconnect all previously disconnected connectors systematically to restore the vehicle's wiring integrity. Once all connections are secure, turn the ignition back to the on second position. Utilize the HDS to reset the ECM and perform the ECM idle learn procedure so that the system can adapt to any changes made. After completing these steps, check for any pending or confirmed DTCs with the HDS. If DTC P2127 reappears, investigate potential loose terminals or poor connections between the APP sensor and the ECM once more. If no DTCs are present, troubleshooting is considered complete. Preventive maintenance is essential to keep a vehicle in optimal condition and to avoid future issues related to DTC P2127. Regularly inspecting wiring and connectors associated with the APP sensor and ECM can prevent low-voltage problems caused by wear and corrosion. It is equally important to ensure that the ECN software is updated periodically, as improvements are often released by manufacturers to enhance vehicle performance and reliability. Routine checks of electrical connections can also help identify potential looseness or corrosion before they lead to system failure, thereby ensuring that all components function as intended. In conclusion, DTC P2127 indicates a low voltage condition in the APP sensor B circuit, significantly impacting throttle response and overall driving experience. To address this issue, a systematic troubleshooting approach is needed, including checking all related wiring, making necessary repairs, and updating the ECM software if it is outdated. By following these steps, along with regular inspections and preventive maintenance, drivers can ensure the reliability and performance of their Honda Civic. Understanding the roles of the APP sensor and its connection to the ECM is critical for effective diagnosis and repair, thus enabling safe and efficient operation of the vehicle. Please like and subscribe to the channel. See you next time.